This exact relation is given in one of your homework problems. And again, you're supposed to select all the properties below which this relation R satisfies. Now, I haven't listed all those properties. Those properties are reflexive, antireflexive, symmetric, anti-symmetric, transitive, or none of the above. And like I did in the previous video, I just want to help you to reason about what a relation defined on this infinite set of sets, how to reason about this relation. Because instead of having A be a finite set like a lot of my videos have been, now we have this infinite set of sets. Okay, so the way I would do that is I would work with a smaller example. And for this, and a good smaller example, I think would be the power set of a finite set. So power set of the set containing 1 and 2. Remember, the power set is the set of all subsets. All subsets of the set 1 and 2. Of the set containing 1 and 2. All right, so the subsets of the set containing 1 and 2, let's see, these are the empty set, the set containing 1, the set containing 2, and the set containing 1 and 2. All right, so the power set of the set containing 1 and 2 is the set whose elements are empty set containing 1, set containing 2, set containing 1 and 2. And so, in using this same relation, we're going to use this same relation right here, right? Now, graphically, we would have 4 vertices, four points. We'd have a point for the empty set. We'd have a point for the set containing just 1. We'd have the set containing 2, and the set containing 1 and 2. Right, and now we want to think, okay, let's start with reflexivity or reflexive. A is related to B if A is a subset of B. Now remember, A and B are subsets. A and B are subsets. They're elements of this set. So for our small example, A and B are any of these sets here. Okay, so is the empty set a subset of itself? Is it true that the empty set is a subset of the empty set? Yes, it's true. That is true. Remember, the empty set is a subset of all sets. So it's certainly a subset of the empty set. And so we have a self loop there. How about the set containing 1? Is the set containing 1 a subset of the set containing 1? Yes, it's true. It is. Now you might be saying, hey, that doesn't make sense to me. Now, you might be thinking of this, right, where it's a proper subset. And that's not true. It's not true that the set containing 1 is a proper subset. But when we put this little line under it there, that means proper subset or equal. Right? So this actually means that's an or statement. Either it's a proper subset or it's equal, just like less than or equal. And this is true. This is false. So true or false is true. So it is true. So because that's true, right, we have a self loop here, we have a self loop here, self loop here. Would that generalize to all subsets of the integers? Think about that. Okay, and once you think about that, then you'll be able to answer whether or not the bigger relation, the relation on the bigger set, the infinite set, is anti-reflexive. Okay, let's see. Now let's go to symmetry. So we definitely have an arrow here, right? This says that the set containing 1 is a subset of the set containing 1 and 2. So would we have an arrow going back this way? Think about that. If yes, then does that generalize to the bigger set? If no, then if it doesn't happen here, then does it happen for all of them in the bigger set? Think about that. All right, moving on. Then you can think about anti-symmetry, transitivity. Transitivity, let's see, how about something like this and like this? Right, the empty set is a subset of the set containing 2. The set containing 2 is a subset of the set containing 1 and 2. Okay, well then would we have this? Is the empty set also a subset of the set containing 1 and 2? So think about that. Using that kind of reasoning will help you reason about the bigger set. Now, I'm not saying that what happens with the smaller set is always true for the bigger set, but often you can reason from a smaller set to the bigger set. And that's it.